Okay, in this video we are going to talk about linear speed and angular speed and how to work between the two. So linear speed is probably any kind of speed that you've thought of before, like how fast is your car going, right? When you're talking about how fast your car is going, you're saying something like miles per hour. So you're saying a straight line distance. This is how many miles we went over a certain time element. An hour or whatever it would be. Angular speed is not how fast something goes in a straight line, it's how fast something spins. And so what you're used to probably seeing that is an angular speed, the most common for you, is probably RPMs, right? You probably see that on your car, and that is saying how many revolutions or rotations per minute. That is an RPM. So a linear would be like miles per hour, and an angular would be rotations per minute, RPM. Okay. So to find these formulas here, the angular speed, we're going to use a variable called omega. It kind of looks like a W, but it's simply going to be the angle that we traverse, however far, whatever angle we are making here, divided by the time element that it takes it to go that angle. Linear speed, the velocity, or v, is equal to s over t, where s is arc length. So I've got a previous video here where I talk about arc length, but if we know the arc length, and we take that and divide by time, that gives us the linear speed. Which means the only difference between those two formulas, if I think about s being r times theta, right, that means this is really r times theta over t. The only difference is r. So if I want to know the linear speed and I have the angular speed, all I need to do is take the angular speed and multiply by the radius, and that would give me the linear speed. Okay, so we're going to use these formulas. A boy rotates a stone in a 3-foot-long sling at a rate of 15 revolutions every 10 seconds. Find the angular and linear velocities of the stone. So if we think about, some boy, he's got a sling that he's whipping around in a circular motion, something like that. Okay, the sling is 3 feet. So if we think about a circular motion being created by that 3 feet, let me give the boy a head here. If we think about a circular motion being made by that 3 feet, that 3 feet is going to act as our radius of that circle. It is going 15 revolutions every 10 seconds. So the number of revolutions is what helps us with the angle. If it goes 15 revolutions, that means that the angle that it has gone is 15 times 2 pi. One revolution is an angle of 2 pi radians. So that is an angle of 30 pi radians, which means that our angular velocity is simply going to be the angle that we traverse, which is 30 pi, divided by the time that it takes it to do that, which is 10 seconds, which would give us 3 pi radians. Every time that you do an angular velocity, it's in radians per time element, so per second, radians per second. Then the linear velocity, the easy way to get linear velocity, if you already have the angular velocity, is to simply take your angular velocity and multiply by the radius. So the radius of the sling is 3 feet. Of the circle created by the sling is 3 feet. The angular velocity is 3 pi. And so if we multiply those things together, we get 9 pi feet per second. And why is it feet? Because the radius was feet. Okay? So that's how you find angular velocity and linear velocity. Another example, a woman is riding a bike whose wheels are 26 inches in diameter. Anytime I see diameter, I want to think about radius, so the radius is going to be 13. If the wheels rotate at 125 RPM, find the speed at which she is traveling in miles per hour, period. Find the speed that she is traveling in miles per hour. So we want her linear speed, miles per hour. That's a linear speed, not an angular speed. So our linear speed is going to be the radius, which is 13, times the angular velocity, or we could think of it as theta divided by time. Well, we go 125 revolutions per minute. So 125 revolutions means that our angle is 125 times 2 pi, which is 250 pi. That is the angle that we traverse, divided by the time element, which it's revolutions per minute, so that's in 1 minute. Now that gives us an answer of 3,250 pi. And then what would that distance be? Well, it's in inches because the radius is in inches. So that's in inches per 1 minute, right? Which means we need to convert this to miles per hour from inches per minute. So I'm going to write this down. We've got 3,250 pi inches per 1 minute. And I need to convert both of these units. I'm going to work on the distance part first. In 1 foot, there are 12 inches. I want to get to miles, so there are 5,280 feet in 1 mile. So we're going to be at miles there. You can see that at that point in time, the inches would cancel, the feet would cancel, and we would be left with miles. However, we would be left with miles per minute. So we need to get rid of our minutes. So there are 60 minutes in 1 hour. And by doing that, we can cancel the minutes out, and we'll be left with miles on top and hours on bottom. So essentially what you're doing here is you're taking this 3,250 pi and multiplying by 60, and then dividing by 12 times 5,280. And if you do that, you get an answer of 9.7 miles per hour. Okay, so make sure you know how to do those conversions. You may need to do that. The formulas that you're actually using for these velocities are pretty simple. It's just angle divided by time, or essentially arc length divided by time to find those.